This is Geometry Unit 9, Day 5. This is the homework assignment for Section 5.1, page 298. So we're looking at question number 21. We're supposed to find the length, the slope, the midpoint of each side of this triangle, and also decide if this is a right triangle or an isosceles triangle. So to find the length, we're going to look for the length of AB. So we're going to use our distance formula, which is x2 minus x1 and y2 minus y1. So that leaves us with p squared plus q squared. Now let's find the length of BC. BC, x2 minus x1, y2 minus y1, 2p minus p leaves you with 1p squared, and negative q squared leaves you with a positive q squared. So those are the same. And we know that AC is the length of 2p. So we know that that's definitely different. So I know from here that AB is congruent to BC, but not congruent to AC. So I know that this triangle is isosceles. Now let's figure out what the slopes are. Slope AB is going to be y2 minus y1, x2 minus x1, so that's q over p. Slope BC is going to be y1 minus y2 and x1 minus x2. So here we still have q and we have a negative p. So the slopes are opposites of each other, but they are not reciprocals. So they are not parallel, they just have different slopes. If they were opposite reciprocals, then you know that you had a right angle. These are not. And we know that the slope of AC equals 0 because it's a horizontal line. So we have no right angle. So we found the length, we found the slope, now we need to find the midpoint. The midpoint of AB is P plus, or x1 plus x2, y1 plus y2. So that's P over 2, comma, Q over 2. The midpoint of BC is P plus 2P, add the x's, add the y's. So that's 3p over 2, and that's q over 2. And then, of course, the midpoint of AC is going to be located halfway to 2p. Number 22. So for number 22, we know we have a point at the origin. We know that we have a point at what's called H. And we have a point that's called 2 H's. Very similar to what we just had in the previous problem, but not necessarily exactly the same. So we're going to look to see what AB is. AB is H minus 0 squared and Y minus 0 squared. Leaves us with H squared plus H squared, which is 2H squared, which comes out to be H root 2. That's the length of our AB, apparently. Now the length of BC is H minus 0 and H minus 2H. So that's H squared plus a negative H squared, which gives us 2 H's that are squared. When you square a negative, you get a positive. And that's going to come out to be, you can take the square root of the H squared, but you can't take the square root of the 2. There's no plus or minus involved here, so it's okay to take the square root. These are the same. So I know that AB is congruent to BC. So I also know that triangle ABC is an isosceles triangle because at least two sides are congruent. We also have AC, and we know that AC has a length of 2H, which is not equal to either one of those others. Next, we'll look at slope. We're looking for the slope of AB. Slope of AB is your y minus your y and your x minus your x, which is h over h, which is 1. Looking for the slope of BC, which is your h minus 0 and your h minus 2h. H over negative h, which is negative 1. These are considered opposite reciprocals. If they're opposite reciprocals, then I know that AB is parallel. Oh, sorry, they're not parallel. Perpendicular to BC. If they were parallel, they would have been exactly the same. But because they're opposite reciprocals, they are perpendicular. And of course, the slope of AC is 0 because it's a horizontal line. Now we're going to look at the midpoint. So the midpoint of AB is x plus x over 2 and y plus y over 2. That leaves us with h over 2 comma h over 2. The midpoint of BC is h plus 2h, those are your x's over 2, and your y's over 2. And then of course we know the midpoint of AC is going to be at h comma 0 because it's half the distance to 2h. So we know that we're perpendicular. If we're perpendicular, two sides are perpendicular, then we know that triangle ABC is a right triangle. It's a right triangle because these two sides are perpendicular to each other. For number 29, we know these two triangles are supposed to be congruent. We have coordinates for several of the intersections, but we're looking for the coordinate of P. So we got to problem solve a little bit what that would be. Well, I'm looking for the coordinates of P. I know that the x-coordinate of P is on the y-axis. So it's 0. And we know that the y-coordinate of P is even with point S. So P is going to be 0, comma, K. For number 30, we know that the slope of HE, whatever its slope is, equals the opposite of the slope of DG. So the rise over run one way is the same numbers of rise, but a negative run of the other way. So I look here and I see that G is the midpoint of AE. So for me to figure out G, so the midpoint of AE is going to be adding the x's together and adding the y's together. So that is h comma k. That is point G. The midpoint of AD, because those two segments are the same, is going to be adding the two x's together, divided by 2, and adding the two y's together, divided by 2. So that comes out to be a negative h, comma, k. And that is point h. Which makes sense because you're half the distance to negative 2h, which is negative 1h, and you're half the distance to k, actually 2k, which is 1k. Half the distance to 2h is 1h, and half the distance to 2k is 1k. For number 36, I have coordinates for our triangle. I need to prove that this triangle is isosceles. So for you to be able to do this, you want to think about what is needed to prove that a triangle is isosceles. What's true about an isosceles triangle? If you don't know what an isosceles triangle is, you can't go about doing a proof. So to prove it, I need to prove that it has two sides that are congruent. I can look here really quickly, and I know that this total distance from negative h to 0 and from 0 to h, that's a distance of 2h. Now I have to figure out what are the distances of the other two sides. Are any of those congruent to each other to make it isosceles? So I need to do distance. So I'm going to find the distance of RP. So RP takes my x2 minus x1 and y2 minus y1 we'll make that be h squared plus k squared. That can't be simplified at all. That's the length of RP. The length of PQ is 0 minus h squared plus k minus 0 squared. When you square a negative, you get a positive. We got the same thing. So here we know that RP is congruent to PQ. We also know that RQ is 2h. So now we can say that this is isosceles because we have at least two sides congruent. Triangle PQR is isosceles because, you want to give your answer, because at least two sides are congruent. Here we have given that we have points for a triangle, and we know that WV is a midsegment. What that tells us is that V is the midpoint and W is the midpoint. We're supposed to prove that WV is parallel to OH and that WV is half of OH. Well, that's what midsegment means, but they want us to actually show that. These are with numbers rather than variables, so maybe it's a little bit easier. So, first we need to know what our coordinates are. So to find the midpoint of GH, that's going to be 6 plus 8 over 2 and 6 plus 0 over 2. That's going to give us 14 over 2, which is 7, and 6 over 2, which is 3. So we're at 7, 3. The midpoint of GO. which is 6 plus 0 over 2, and 6 plus 0 over 2, which is 3, 3. That's what W is. So now I need to show that the lines are parallel. So I'm going to look at the slope. The slope of WV equals 3 minus 3 and 7 minus 3. That's 0 over 4. That's 0. The slope of HO is 0 minus 0 and 8 minus 0. That's 0 over 8. Anything above or anything under 0, as long as it's not 0 over 0, is 0. Even though the denominators are different, they're still the same slope. Okay, that's going to make WV parallel to OH, or in our case, I wrote it as HO. The other part I have to show is that my distance for WV is half the distance of OH. So WV is 7 minus 3 squared and 3 minus 3 squared, which is 7 minus 3 is 4. 4 squared, which is 16, so it's a length of 4. Now I have to find the length of OH, which is my x minus my x, and my y minus my y. That's 8 squared. Take the square root of 8 squared, you get 8. So I'm supposed to show that WV equals half of OH. 4 equals half of 8. 4 equals 4. That worked out.